All right, so, okay, so we now know what vectors are, and we now know how they look and what we could do with them. Here's a little bit more that we could do with them. It's always useful when you take anything and put it in the coordinate plane and assign coordinates to it, because then you could manipulate them to a greater degree. Okay. So if you have a vector, okay, you can write the vector in component form. So basically, look at this blue vector here, all right? And if I wanted to describe that vector, one thing I could do is, okay, in order to, to draw that vector, I could say, okay, you start at point A, and then you go to the right 4 units, and then you go up 3 units, right? And when I give you those explicit directions, you can draw the vector precisely, right? If I said, okay, go to the right 4 units and up 3 units, you can draw exactly what vector I'm referring to. All right? So how do we express this in coordinates? All right, so suppose this had coordinates, this point A had coordinates 5, 6. All right, hang on. Okay, go. And suppose B had coordinates 9, 9. All right. How much, in order to draw that blue vector, how much do you have to go in the horizontal direction? How much would you go in the horizontal direction? 4. How did you do that? You subtracted x1 and x2, right? You did x2 minus x1. So how would you know how much to go up? You do y2 minus y1, right? And that's how you would get 3. So now, instead of saying go to the right 4 and up 3, if I wanted a more concise notation, one thing I could do is go to the right 4 and up 3. And that looks like so many different things. That looks like a coordinate point. That looks like a whole bunch of different things. So if I wanted to give it a notation unique to a vector, I could do maybe a bracket that looks like that. Okay? And that's how vectors are symbolized. That notation, that bracket, that, triangular bracket, if you want to call it, that's the notation for vector in component form. So this is vector AB in component form. All right? So more formally, this is the formula for it. So you've got that triangular bracket. I don't know if it's called a triangular bracket. This is the first time I'm using that term. It just looks like that. And then it's x2 minus x1, y2 minus y1. Now, what happened if you did x1 minus x2? What happened if you did 5 minus 9? What would you get? -4. In which case, in which direction would you go? The opposite direction. So that's not cool. You can't do that. All right? It's got to be in the proper order, y2 minus y1. All right. So in this one here, I want to find the component form of AB with initial point this and terminal point that. So let's do that. What I do is I say vector AB is equal to, and it's always B minus A. So 1 minus 0, 1 minus 1, 3 minus -3. So AB is equal to 0 and 6. What does that tell me? That tells me in order to draw AB, start at a point. How much are we going to go in the horizontal direction? 0. And how much in the vertical direction? 6. Okay, so does that make sense? Let's see. Where is point A? It's at 1, -3. Where is point B? 1 comma positive 3. How do you go from A to B? You go 0 in the horizontal direction and 6 units in the vertical direction. Like, oh my God, how cool is that? That is exactly the exact representation of that vector, right? How awesome is that? Like, you gotta leave it to math, you know, for like clear, concise, to the point. There it is. Boom. Huh? So what is the magnitude of a vector? It's the length of a vector. How do you find the length of any line in math with the coordinates? You use the distance formula. So, in order to find the distance of this line, right, if that's vector v, in order to find the magnitude, right, I have to, okay, so if this is A and if this is B, what would the distance be? It would be the square root of A squared plus B squared. Okay? Now, if this horizontal line has the name A, how did we find that horizontal line? How did we find that? We did x2 minus x1, right? So I could also say, wait, I could find the distance by doing, instead of A, what's A? x2 minus x1 squared, exactly, plus y2 minus y1 squared. Okay? So there it is. Most of the time, when we're in the world of vectors, and I want to find the magnitude of vector v, I don't do x2 minus x1. I shorten things and I say, okay, if this has a length of A and that has a length of B, then the magnitude is going to be the square root of A squared plus B squared. Yes?
Wouldn't the square root and squares cancel out?
No, they don't cancel out because, okay, so again, we've said this before. If you have 16 plus 25 like this, that's the square root of 41, right?
Yeah.
Okay. But if you did the square root of 16, 4 plus the square root of 25, 5, that would be 9. But that's not what that square root represents. Okay? So we can't cancel that way. Okay. So here we go. This is it. So if you were to go right now, if you were to like step into, I don't know, a physics professor's room, if you were to step right now into like a JPL, right? That's the formula you would see then. Okay? All right.
Is that the one you want us to use?
That's the one. That's what we do. It comes from this formula, but we don't use that form in the world of vectors. Okay. So here, find the magnitude of AB with initial point this and terminal point that, right? Okay. So this is the same exact vector from before. So in component form, you don't have to put it in component form first, but since we already have it in component form, AB is equal to 0, 6, right? So the magnitude of AB is the square root of A squared, 0 squared. Yeah, hang on. And then B squared, which is 6 squared, right? So how much is the magnitude of AB? It's just 6. Does that make sense? Here is our vector. Does it make sense that it's got a length of 6? Yeah. Yes, it does. Okay. So do you see now how this works? Yes. No. Yes. Okay. If you have questions, away. Like there is, oh my God, like you have no idea how in love I am with vectors. Like just no idea whatsoever. Okay. So adding, subtracting, and scalar multiplication resembles that of matrices. Okay, meaning, okay, if I have a vector A, okay, so suppose the vector's name is A. It's got two components, right? Instead of labeling these A and B, right, because this is part of vector A, I say, okay, that's A1 and A2, right? So I don't run out of letters. Remember how in matrices, one way to label things was X1, X2, X3 instead of W, X, Y, Z? And then if I have a vector B, I call it B1, B2. So now, if I wanted to add two vectors and I had them in component form, all I do, just like matrices, is add corresponding terms. A1 plus B1 goes here. A2 plus B2 goes there. Let's just do an example because it's easier. Okay, I've got vector W, Y, Z. Here I want 2W plus Y minus 4Z. Okay, so this is 2 times vector W, 2 comma negative 5, plus vector Y, minus 4 times vector Z. Okay, here, that's going to be scalar multiplication. So I'm just going to distribute the 2. So that's 4, negative 5, plus 2, 0. Okay, now, hang on. Sorry. Now, for this one here, you're sophisticated math students now. So it's up to you whether you distribute the negative and put a plus here or you don't. Right? In fact, let's just do that. So let's do plus and then let's distribute a negative 4. So I get 4, 16. Okay? Right. We call it, so all the, ones and then all the 2s. So here it's going to be 4 plus 2 is 6 plus 4 is 10, comma, negative 10, 0, 16. How much is that? 6. Okay? All right. Go ahead and do the next one. I'll race you to it.
Are these all scalar multiplications?
So 3 times y is scalar multiplication, and then we're adding or subtracting. All right. Anybody? What do you have? I have an 8, 8. Any other answers? Okay. So I got 8, 8. Okay. Now, if we wanted to find the magnitude of that, okay, so the magnitude of that, what would it be? The square root of what? That's the one, 8 squared plus 8 squared, right? So this is my vector, and if I wanted to find the magnitude of that vector, it'll be 8 squared plus 8 squared. That's the square root of 64 plus 128, and then you simplify. You can't, right? Okay. I knew what I was talking. I knew what you were talking about. Okay. So for homework, I would like you to do 7, 9, 17, 19. 7, 9, 17, 19. And also the worksheet that I'm just going to give you. All right. So for this worksheet,